Hello guys, welcome back to my channel. Today I'm going to explain the solutions of the first 5 problems in Codeforces round 644 division 3. So in the first problem what we're asked to do is that we're given some queries, and each query contains two integers a and b that denote the dimension of a rectangle, and we need to find the minimum area of a square that can fit two of these rectangles with dimensions a and b. So let's see a basic approach. The basic approach is just we can divide the problem into two cases. The first case is to put these two rectangles one on top of each other, but we can put for the height of this rectangle a side A. So we have created a rectangle with height 2a by putting these two rectangles each on top of each other and width b. So in order to make this square, we have to fit both sides that have length 2a and b. So the side of the square will be the maximum of 2 multiplied by a and b. So in order to find the area of the square, we have to take the side, so maximum of 2 multiplied by a and b squared. And the second case is the exact same thing, but with height b and with width a. So we have to put each rectangle on top of each other and put the sides. The height will be b, and on the width we have to put a. So we have to just rotate the rectangle from a to b, to b to a. So we have created another rectangle with height 2b and length a, width a. So in order to fit this into a rectangle, we have to take the maximum of those two sides. So we have to take the maximum of 2b and a, and just this will be the side of the square. So we can just square it and find the area of that square. So we can just take the minimum of those two areas of those two squares we have created and just output, and that will be our answer. So that's it basically for the first problem. So I'll just try it on an example. Let's say we have a equals 3 and 2 equals and b equals 2. So that means we have to take the maximum of 2 multiplied by a and b. So maximum of 2 multiplied by 3 and 2 is 2, 6 actually. So we have to take square that 6. So the first square will have area 36, and the second rectangle will have a maximum of 2 multiplied by b. So 2 multiplied by b is 4, and maximum of 4 and 3 is 4. So we have to square it. So 4 squared equals 16. So we have two squares with one of area 16 and the other one with area 36. So the minimum of these two is 16. So we see the correct answer is 16. So that's it for the first problem. Let's go to the second problem. So in the second problem, we're given an array A full of integers, and we need to divide that into two subsequences, and we don't care about the order. We can just take random elements in any indexes and divide that into two teams, such that the maximum element from the first team minus the minimum element from the second team is as minimum as possible. Actually, the absolute difference of these two is as minimum as possible. So for example, say we have the array 3, 1, 2, 6, 4. So we can just take in the first team the elements 1, 2, and 4, and the second team the elements 3 and 6. So the absolute difference of the maximum element of the first team, which is 4, and the minimum element of the second team, which is 3, is 1, because absolute difference of 4 and 3 is 1. So the key to observe here is that we can just sort the array. So for example, if you have the array 3, 1, 2, 4, and 6, the key is to sort the array. So we have the sorted array 1, 2, 3, 4, and 6, and we can observe that if we make a cut between each index, so we can just check every index and just make a cut. So this cut will divide the array into two teams. So the first team will be team A and the second team will be team B. So for example, in the array 3, 1, 2, 4, 6, we can just sort it into 1, 2, 3, 4, and 6. So just divide in the first index. So the first team will be 1, only of element 1, and the second team will have elements 2, 3, 4, and 6. So we can just do it for every index, and what we'll observe is that, say for example, we can divide it here. So the first element has the first array has elements 1 and 2, and the second array team has elements 3, 4, and 6. So what we observe is that we want to find, as in the problem stated, we want to find from the first team the maximum element. So as we see, because the array is sorted, the maximum element from the array, from the first team, will be actually the number right next to the cut we have made, right left to the cut we have made. So we have made a cut between 2 and 3. So the maximum number from the first team, so from the left subarray, let's say, will be 2. And this will be is actually 2 is actually the number right next to the cut we have made, because the array is sorted. And the minimum number from the second subarray, 3, 4, 6, is 3, and 3 is actually also the next element from the right subarray between the cut. So say for example we make the cut between the element 3 and 4. So the numbers right next to the cut are 3 and 4. So from the left we have the team with elements 1, 2, and 3. So the maximum of these two is 3. And in the second team, the elements we have elements 4 and 6. The maximum of those two elements, the minimum of those two elements is 4. So the absolute difference between the maximum and the minimum, the maximum from the first array and the minimum from the second array, is 1. So we see that 3 is right next to the cut, and actually we see that 3 is the maximum number in the first team, in the first subarray, that contains all numbers 1, 2, and 3. And 4, which is right next to the cut, in the right side, in the right subarray, is actually the minimum number in the second team, the second subarray. So that is all for the second problem. So all in all, in the second problem, the key is to observe that we need to sort the array, and because it's sorted, when we cut it into some index, say index I, the element at index I-1, where I-1 is greater than or equal to 0. So yes, the element at index I-1 will be equal to the greatest element in the right subarray, in the left subarray, because it will be sorted. So the last element will be the maximum, and the same thing in the right subarray. The first element right next to the cut in the right subarray will be actually what we want to be in the second team. So we want to be the minimum element in the second team, because we want to find the maximum element from the left subarray and find the absolute difference of that with the minimum element from the second subarray. So because it's sorted in the second subarray, the first element right next to the cut will be the minimum number. So that is for the second problem. Let's move on to the third one. So in the third problem, we're given some integers, another array, and it is declared that we can just pair two numbers, either if they have the same parity, the same remainder when divided by 2, or their absolute difference is 1. And we need to find if we can pair all the numbers in the array. So we can just output yes or no. So the key here is to take two arrays. The first array will have all even numbers, and the second array will have all odd numbers. So for example, in the array in the first example we have 11, 14, 16 and 12. So I'll just write that down. We have 11, 16, 14 and 12. So we have to take in the first array called, say, even, the even numbers. So even will have 12, 14 and 16, and odd will have only 11. So we can just check at first if even the size of the even set we have created, the even array, is even, and also the size of the odd array we have created is even. So it means both arrays contain even numbers, even count of numbers. So that means we can just pair every number. So for example, we have in the even array 12, 14, 16 and 18. So we have 4 numbers, and in the odd we have 5, 7, 9 and 3. So we have also even count of numbers. So that means we can pair each number with another number in the array, because each number in the array has the same parity. So we can just pair 12 with 14, we can just delete it, and pair 16 with 18. And then delete, because we have paired 5 with 7, and delete again 9 with 3, because we can just pair it. So we can just check that at first, if both sizes of the even set we have created in the odd are even. So we can just output immediately yes. Otherwise, we're given the statement that n is even. So in order to n to be equal to an even number, so either the even size will be even, and again the odd size, the size of the odd array will be even, or we'll have, actually yes, or the second case, so that the numbers can be even, is to have even in the first and odd in the second one. Actually, odd in the first and odd in the second one. Yes. So for an n, number n, to be an even integer, and when the size of the first array called even, that stores all even numbers, must be either even, and the second size of the odd numbers must be again even, or they must be both odd. So because say we have n equals 8, so 8 can be done by 4 and 4, which are both even, or it can done by some two odds. So for example, say 14 can be made by 7 and 7. So we can't have even size in the array even and odd size in the array odd, or the exact opposite, odd size in the array even and even size in the array odd. We need them to have the same size parity. So they need to either have both even size or both odd size. So we have found the case if we have both even size. We said if they have both even size, then it's immediately yes, because we can just pair every number with it. Either otherwise, if they have both odd size, and that means we can just pair every number in every array of even and odd, except one number in each pair, in each array. So that means in the example where the array equals 11, 16, 14 and 12, even equals 12, 14 and 16, and odd equals 11. So each array has odd size. The first has 3 and the second has 1. So 3 plus 1 equals 4, which is also an even number. Okay, we don't care about that. So we can just pair every number in the first array equal even, except one number. So we can just pair 12 with 14, and 16 will be left out, or we can just pair 12 with 16 and 14 will be paired out, or we can just pair 14 with 16 and 12 will be left out. So we can just take each of these cases. So we can just check every number in the even and say check if this element is to be left out. Then that means that we need to pair it with a number that has absolute difference with it, 1, with another element of the odd. So that means, for example, we just check if 16 will be paired out. So that means 12 and 14 are paired, so we can just delete them, and 16 will be left. But 16 can't be paired with any other number, even in the odd array, because the only number in the odd is 11, and the absolute difference between 11 and 16 is 5. So we can't pair it. So 16 will not be left out. And we can just do that for the other numbers. So if 14 has to be left out, then that means that we need to find another number in the array even, in the array odd, that has absolute difference with 14, 1. But the only number in odd array is 11, and the absolute difference between 11 and 14 is 3. So 14 will not be left out. So we're left with a number 12. So this means 12 will be left out, and we can just check if this number that we have left out can be paired with a number in the odd array. So there can be a number in the odd array that can have an absolute difference 1 with this element, which in this example is because absolute difference between 12 and 11 equals 1. So it means we can pair the element 11 in the odd array with the element 12 in the even array, because we have absolute difference 1. So we can just pair 12 with 14, and actually we can pair 14 with 16, and we can just pair then 12 with 11. So let's see another example. Let's see here the example 1, 2, 5, 6. So we have 1, 2, 5, 6. So the even array will have elements 2 and 6, and the odd array will have the elements 1 and 2 and 5. So they both have, wait a moment, yep, 1 and 5, not 2, sorry. So even we have elements 2 and 6, and odd will have elements 1 and 5. So they have both sizes even, 2 and 2. So every number can be paired with the other number in each array. So 2 can be paired with 6, and 1 can be paired with 5. Let's see a case where they have both odd sizes. Let's see this case. Yep, 1, 6, 3, 10, 5, 8. So the even array will have elements 3, oh actually no, it will have 6, 10 and 8, and the odd array will have the elements 1, 3 and 5. So they both have size 3, so they're both odd, they have both odd sizes. So we can just pair 6 with 10, and this means that 8 will be left out, or we can pair 6 with 8 and 10 will be left out, or we can just pair 8 with 10 and 6 will be left out. So if 8 is left out, then it means we have to find a number in the odd array that has absolute difference with 8, 1. But in the odd array we have only elements 1, 2 and 5, so nothing of them matches 8 with absolute difference 1. So 8 is not left out, 8 is paired with something. So if 10 is left out, then that means we have to find an element in the odd array that has absolute difference with 1, but again we can't find because the only element are 1, 3 and 5, and with 10 they have at least absolute difference 5, so it can't be possible. So our only case is that 6 is left out, and 6 can be paired actually with 5 from the odd array. So that means 8 will be paired with 10, and 1 will be paired with 3, and 6 will be paired with 5. So we have met all our cases, and so yeah, actually that's the solution for the third problem. Let's go to the fourth one. So in the fourth problem we're given two integers, n and k, and the k says we have k packages, actually k types of packages, and the ith type has isovels, let's say imarbles, let's say. So we need to find the minimum number of packages so that we can have exactly n marbles. So that means, but we need to take exactly one type of package. For example, let's say we need to take 8 marbles, and we have 7 types of marbles, and the first package actually has 1 marble, the second package has 2 marbles, and the third package has 3 marbles, until the 7th package, which has 7 marbles. So we need to take a package and take some of these packages of the same type, so that we can have at the end exactly n marbles. So the solution about that is to just take the divisors of n, because we need to take of one type, and if we take, say, the ith type, and we have to take k, say x of the ith type, so that means x multiplied by I will be equal to n, because we have to take only one type. So we will take the type of package I, which will contain I marbles. then we have to take some of these of the same packages so that we can have exactly n marbles. So that means if we take x packages of I marbles, then x multiplied by I equals n. So that means n can be is a divisor of n. So n can be divided with I, with the number of package and of marbles in the package. So we can take all divisors of that number of n. So for example, when n equals 8 and k equals 7, we can just take all divisors of 8, which is 1, 2, 4, and 8. And it means we can take for every divisor, say for divisor 1, that means we can have, we take one package. So it means 8 divided by 1 is 8, so we can have one package with 8 marbles. Or we can have 2 packages with 4 marbles, or 4 packages with 2 marbles, or 8 packages with 1 marble. So that means we can have for every divisor I of n. So it means for every divisor of I, then we can take I packages of marbles and divided by I. So when we multiply them, I multiplied by n divided by I equals n. So yeah, that's correct. So we can just find the divisors of n, and then just take each n divided by I, each n divided by each divisor, and check if that is smaller than or equal to k, because we need to have at least at most k marbles in the package we select. So we just check if n divided by I is smaller than or equal to k, and we can just take the minimum of the result. So that's actually for the fourth problem. So let's move on to the fifth one. So in the fifth one, what is basically said that we're given a matrix, and this matrix cell contains either 0 or 1, and in the side of this matrix we have some cannons, and these cannons shoot some ones, but they shoot them at the end of the row or the column. So for example, if here in the example the cannon in the row 2 shoots, then we have one at the end of the row 2. Then if it again shoots, then we have another one in the row 2, in the second last place of row 2. And then if the cannon in column 3 shoots, then because it is blocked by row 2, because cannon in row 2 shoot in the previous 2 moves, then it will have one right here. So the key here to observe is that for every number 1 in array, in our matrix, we need to check for every row and for every column except the last row and the last column, if we need to check for every number that is 1, so that means it has been shot by cannon. We need to check its adjacent neighbors right and down. So it's actually easy problem. So we need to just check for every one in our matrix. We need to check if both adjacent cells right and down are 0. Then that means that there cannot be solution. This isn't the solution, because if it is 1, the current cell is 1, then it means another cannon has been shot, and that means that either the right element, the right cell of the current cell we're at, or the cell down from that is 1. So let's just see the code for that one. Yes, so you can just traverse the array and check if the current element equals to 1. Then if either the right neighbor or the neighbor down from that are both 0, then we can continue. Otherwise, we can just print yes or no based on the decisions we've made. So that's all for the first 5 problems. Let's just now see the codes again. So in the first problem, actually you've seen the code. So yes, we just check the maximum of 2 multiplied by a and b. We've seen that. Let's go to the code of the second problem. We haven't seen that one. Yes, what we do is just sort the array and just take the minimum difference between all the adjacent elements. So that means we can just check for every cut in between each index in array, as we said before. In the third problem, let's see the code. Yes, we just have two arrays called even and odd, so we store the even elements and the odd elements. We just check if both sides are even, so that means absolutely the answer is yes. Otherwise, that means both are odd sizes, and we can just check if for each element is to be left out, and then that means then we have to pair it up with another element of the odd array that is left out again. So we have to check if it exists either the element plus 1 in the odd array, because they can have an absolute difference of 1, either minus 1, because we have to take the absolute difference to be paired up to be 1. And for the fourth problem, let's see the code. We can just take, yes, we traverse until the square root of n. We just take all divisors in the vector called divis and just check if n divided by that divisor is smaller than or equal to k. Then we just take minimum of this divisor, as we said before. So that's all, guys. Thank you very much for watching. Hope you liked the video. Sorry for the mistake and things next. Make sure to subscribe. See you in the next video.